Okay, so it asks us to go over box plots, which are those funny looking shapes on a graph we're going to build like this. And we have to know the interquartile range, which is also known as IQR. Okay, so they'll write it like this in your book, the IQR. They've given us data here. There's a couple pieces of information we need to do. Median is going to be the most important when we first start to go into our box plots, but mean is always a good thing to have, and the mean is the average of something, okay? So the very first thing we're going to do is find the mean of all of this. Now this is a sample. They haven't told us what this data is about. We don't really know, but we're just going to go about finding the mean. They'll denote mean, they'll call it like this, X bar, okay, with a bar on top. And all that is the mean of something. And to find it, they'll write in your book, they'll write something where you do x subscript 1 plus x subscript 2, blah, 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 to xn. Very confusing. And then they'll tell you to go all above n. Math-wise, it can be confusing. All they're saying is take all of the data, okay, all the way to whatever the last number in the data is. So let's actually figure out how much data we have. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have 12 pieces of data. In other words, this n becomes the number 12. They want us to take the first one, so this guy, plus the second one, and they put dot, dot, dot saying continue that. So all they're saying is take all of the information here and add it together. So they want us to sum all of these numbers and divide by the total number there is. Well, we know that x bar, or the mean, we know that there's 12 pieces of data, right? So in other words, we're going to divide by 12. It's the same as finding the average. And we have to actually sum all of these numbers with each other. Okay? Dot, dot, dot. We'll keep that going. So we'll quickly do that on a calculator here. Okay? So we got 110 plus 113 plus 116 plus 118, 120, 122, 124, 126, 132, 134, 144, and 164 equals 1,523. Okay, so that's what this all adds up to, 1,523. So all this was talking about was adding up all of the terms, okay, and that's what we got on top here. And then they want us to divide, n stands for the number of terms there are. So we add them all up and divide by that number 12, okay? Yeah, so we get in our calculator, divided by, where's my division? There it is. 12, 126.91, let's say. Okay, so our mean is 126.91, roughly. Okay, so that's our average, also known as the average, okay? That's what your mean is. That's good to know, that the average is 126.9. Now that's different from the median, okay? The median means middle term. Okay? That's what our middle term is going to be. And I guess we'll write mean just on the side. Mean means average, we'll say, so we know that. Average. Okay. So we have to find where we have to split this data into two. Mean would be the middle term. And in terms of making our box plots, we actually have to figure out where the middle of this is. So because there's 12 terms, what would technically be the middle of this? Do you happen to know? What would be half of 12?
What is half of 12?
Well, because there's 12 terms in general, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, we have to figure out where the middle is. So we divide that in half. So we got to do our 12 divided by 2, which is going to give us 6, right? Mm-hmm. So in other words, we count 6 terms in. So 1, 2, 3, 4, 5, 6, okay? So that means if I put a little bar here, we'll do it in red. If I put a bar here, that's going to be splitting our data in half, right? Because if you look, I'm going to have 1, 2, 3, 4, 5, 6 terms, and 1, 2, 3, 4, 5, 6 terms. So I have 6 terms on both sides. I've just set that up by splitting this in half. Mm-hmm. Now, technically, when this happens for median, we actually have to take, because there is no term right in the middle, right? We actually have to take these two terms, add them together, and divide by 2. We have to find the average of those two terms. Now I'm going to tell you really quickly that when we do that, it's going to be 123. Okay? It's the median. I'll show you how we do it. 122. So we take these two terms that are closest to this middle, okay? To find out the true, because they want an actual value for median. So we're going to find the median. We take 122, right? We find the average again, plus 124. And because there's two of them, we divide by 2 and 123. So it happens to be, even though it's not in the data, the median would be 123. It's not included in the data, though. This number is not included for what we're doing. Okay? But what this has done is we've now split this in half. And that's really important for our box plots in our quartiles. Okay? So we have 6 terms and 6 terms on each side. Okay? Now, that gives us what's also known as the second quartile. Okay? That's our Q2. The middle is going to be our Q2. Because quartiles mean quarters. So we put the data all in a row, and they'd already given it to us in a row. It's all in order. And we split it. We're splitting it into quarters. The easiest way to do this is to split this in half, and then to take this information, split it in half, and take this information, split it in half. And that will give us 1, 2, 3, 4. 4 quarters of the data. Does that idea kind of make sense?
Yeah.
Yeah? Okay. I'm going to rewrite it quickly at the bottom so that it's a little more organized, okay? Okay. So if you look, I just rewrote the information, and I pretty much split it in half by our median, okay? So now we had half our information here. So I've put this in half. Our median is still right down the middle, and we called this our Q2, okay? But in terms of our interquartile range, Q2 is not actually the important things. That's only the median. So we're going to split this number in half again. So there's 1, and I'm just going to focus on the first part here. Okay, so we have 1, 2, 3, 4, 5, 6 pieces of information. That's okay. So because there's 6, we're going to take that number. Okay. So like we said, there's 6 pieces of information here now, right? So we're going to take that term, which is the number 6, and we're going to divide it by 2, which is going to give us 3. So in other words, to split this in the middle again, that means there's going to have to be 3 terms on each side of the split. So our split would be after the third term. So we have 1, 2, 3. So that means our split is right here this time. Okay, so here's our split, and that makes sense, right? Because we now have 3 terms here and 3 terms here. We're going to do that same thing on this side. And again, because there's 1, 2, 3, 4, 5, 6, same idea. We count 3 terms in, and we split it down the middle. Okay? So we split that down the middle. Well, what these are actually our quartile 1 and our quartile 3. Okay? So we've now split these all up. And in order to make a box plot, the idea is from that first quartile, we kind of draw our box to the third. I'll use this one. And draw a box across to the third. So this would be considered what's known as our interquartile range, okay? So all of this is the IQR. So all the information, not 3, IQR. I was thinking from quartile 1 to quartile 3, IQR. And what this is all the data that is in the interquartile or within quartile 1 to 3. Okay? Oh. So if you notice, we split this into quarters. If you quickly look, right, I have 3, that's 1 quarter, 3 more, 2 quarters, 3 more, 3 quarters, and 3 more. That's 4 quarters. Oh, okay. So we split this into 4 quarters now. And they usually use fractions to talk about this. To the left of the first quartile is 1 quarter of all the data, while to the right of this guy is 3 quarters of all the data. Okay? To the left of quartile 2 is 2 quarters of all the data, and to the right of quartile 2 is 2 quarters of all the data. And 2 quarters is also known as a half. That's the same fraction. So I would say or 1/2. That's what that means. Okay? In other words, half the data is before, half the data is after, which makes sense because it's a dead in the middle. Mm-hmm. And the third quartile, we would say to the left of it, we have 3 quarters of all the data. And to the right of it, we only have 1 quarter of all the data. So pretty much the first quartile and the third quartile are kind of opposites of each other in terms of how much data is before and after. Okay, and they're not talking about only what they're talking about is the actual data in this. Okay, remember these are the original numbers. Okay, now I know normally they draw this on a Y chart, right? And what we're going to do is we're going to set up a box plot to look up and down on a Y chart, and then get the whiskers after that. Okay.
Okay.
Now that we've identified part of our box plot, and we're going to get into that a little more, we actually have to get values for Q1 and Q3, just like we did Q2. Q2 was also the median term. And if you remember up here, we added the two numbers on the outside closest to the median and divided them by 2, and we got 123, right? So that happened to be what Q2 is. I'll write that in again. Q2 happens to be 123, which isn't as important for our outliers, okay? But we do have to find Q3. So for Q3, I take these two terms, 132 and 134, because Q3 falls between them, add them together and divide by 2.
To find the
132 plus 134. In other words, I'm finding the average of those two numbers again.
Oh. Okay.
Because it's Q3, if we had an odd number of terms, it'd actually fall right on a term. We'd have an actual number. But because it falls in between two things, we have to get an actual value for this.
Oh, okay.
So for Q3, we take those two terms to the left and to the right of it.
So
Okay? So as an example of this, let's say instead of 6, there happened to be a 7th term, 170. Well, the middle would be 1, 2, 3, 4, and then there'd be 1, 2, 3. So this 4th term would be Q3. He would be 134. So there'd be nothing to find.
Oh.
But because it's an even value, it falls right in the middle. So we actually have to make up a number for it. So we take the average of the two numbers closest to it in the data, which happen to be 132 and 134. And the average is going to be 133, but I'm just going to show it to you anyway. So 132 plus 134 divided by 2. Oh, what the heck happened there? That's not right. 132 plus 134 divide 2. There it is. 133. Okay, so that's Q3. He's 133. Okay, I'll write it down here. 133. And Q1 is the same idea. We take 116 and 118. And instead of dividing it, I'll let you do that kind of on your own. I'm just going to erase this 1/6 so we know this here. That's going to be 117. Okay, and you can test it out yourself if you like. So the interquartile range is actually a formula. And what you do is you take Q3 and you subtract Q1. Well, we have values for those now. Okay, so Q3 is 133 and Q1 is 117. So we subtract those two terms. 133 subtract 117. 16. Okay, so interquartile range is essentially 16 terms. And that's how many terms kind of fall in between. That's our value of the interquartile range. Okay, so then we have to find outliers of the data. So we're going to go on about graphing this stuff, but there's a couple formulas they've given us for outliers. Outliers of the data have to do with data that is 1.5 times the interquartile range outside of our Q1 and Q3. Okay, so in other words, to find out where these things should really end, if we're going to draw a box plot, we're going to take our interquartile range, multiply it by 1.5. So 1.5, so we take IQR and we multiply it by 1.5. Okay? And this is going to tell us how far back we can go from Q1 and how far forward or upwards we can go from Q3 to put our whiskers at the end. Okay? So let's actually find out how far that is. Well, IQR happens to be 16, right? So we take 16 times 1.5. It's going to be 24?
24.
Yeah, 24. So this 24 is important. What that means is we go 24 back from 117 and 24 up from 133. The way we figure that out is take 117 and subtract 24. Okay, so we take Q1 and subtract, and I'm going to write it as a formula, okay? So Q1 subtract IQR times 1.5 gives us bottom whisker, I'm going to call it. Whisker. And Q1 was 117. IQR times 1.5 was 24. So the bottom whisker is 793.
117
minus 24. 93. Great.
But how come, am I supposed to put times 1.5?
I already did that. That's how we got 24. We did IQR, which was 16. Right?
Right.
And we multiplied by 1.5. I just plugged in for that whole part. We knew it was 24.
Oh,
right?
okay.
So we knew it was 24, so that's where I got that term. And the upper whisker, I guess we'll do it in green. Upper whisker would be Q3 plus the IQR times 1.5. Well, we already know what IQR times 1.5 is, right? It's going to be 24. I'm going to call this the upper whisker. This is where the upper whisker ends. Okay. Well, Q3, we jump back up, is
133.
133, right? So 133 plus what happens to be 24 in this case will be 157?
Yeah.
157. Okay, so all really important pieces of data. So we're going to graph this on our second page here. Let's see if I can get dual pages going. Okay, so we'll scroll down a little. All these numbers are really important for us now. So we kind of want to get a graph going here. Set this up here. This is for our bar graph. Or sorry, our box plot, not bar graph. Okay, so we have our data. And we know that if you look at this, it starts at 110 and goes all the way to 164. So how many points do I have here? 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm going to extend this line just a little, and we're going to go by tens. Okay? So what I mean by that is if we start here at 0, this would be 10, 20. Next one would be 30, so 40, 60. Do you know how I'm making this? Is this making sense? I'm just going up by tens and I'm skipping one so that I can see the numbers a little easier. 20, 140, 160. Okay? And if we look at our box plot, so we're going to have to estimate as best as we can. Q1 was 117. Okay, so 117 is, if this is 115, it's probably about here-ish. That's 117. And that would be our Q1. Okay. We don't normally write Q1 in our box plot, but that's fine. It's just the bottom part of it. And our upper part was 133. Well, 133, oh, sorry, I drew that a little off. That should be 110. So 17 should be a little higher than this in terms of my estimate. Yeah, because this is 110, right? So 117 is probably about here. And 133 would probably be about here. So we drew this a bit large for scale, but that's fine. So this would be our box plot, okay? This is where Q3 is at 133. And this is our Q1 at 117. Well, we know our whiskers. Where did our bottom whisker go down to?
95.
93. So 93 is probably about here. Okay? So then in other words, we would draw our line from there to here. That's our bottom whisker. And then our upper whisker was how high?
157.
157, that's right. So 157 is about here, right? That was 157. We'll draw our line to it. And then I just want to write the number for the other one so we know. 193. Okay, so this is our box plot. We've set it up properly. You know, we might want to get a little more detail in terms of our values, but we've estimated quite well. Now let's look at our data. What's our lowest piece of data?
110.
So does that go below 93?
Yes. Oh, no.
No.
Whoa.
So it's within this range, right?
Yeah.
So it's not an outlier. Well, let's look at our highest piece of data, which is what?
164.
Is that above 157?
Yes.
Yes. So he would be considered, let's say 164 is here.
That's an outlier.
This would be our outlier. Okay? 164 is an outlier.
Okay.
L-I... I don't know how to spell it.
E-R, outliers?
I don't know if it's like a letter. That's fine. Not a big deal. Yeah, let's just go here. That would be our outlier in the data. Okay? And 144, the next one, falls underneath that, so it's great. So all of this data pretty much fell in this range. 164 would be our outlier. We found the interquartile range. Let's leave that. We found the interquartile range by splitting in half and splitting those in half. We set up our box. We know that it was from quartile 1 to quartile 3, so that's 117 to 133. And then we got a value for the interquartile range by subtracting those two, and we got 16. You multiply that by 1.5 to find out how high and low we go. So really this line here represents a movement of 24 up from this guy. And this one represents a movement of 24 down. That's how we got to those numbers. It's a distance of 24 to the end whiskers. Okay, so all of the data should be falling inside of that box plot. The box stands for the Interquartile Range. The whiskers deal with that 1.5 up and down. And the stars deal with any outlier data.
All right.